Hello student, good morning. Today we will discuss the chapter number 4, that is polynomials. In the polynomials we have to discuss whatever the important terms is there, no, that important terms. Okay, let us see one by one. Polynomials, an algebraic expressions in which the variable involved have only non-negative integral powers is called a polynomial. Since observing carefully in the example, 3x plus 4y. Such a type of equations we can call it as the polynomials. Okay. Next, constants. A symbol having a fixed numerical value is called a constant. Okay. Since in a polynomial 3x plus 4y, 3 and 4 are the constants. First, you can understand what is the constants. Constants means fixed value. They have the fixed value. Now, you can observe the polynomials. What is the polynomial here? 3x plus 4y is the polynomial. Okay. 3 and 4 are the constants and fixed value. Whatever the x and y is there, no, they don't have the fixed value. Okay. Next, variables, a symbol which may be assigned different numerical values is called as a variables. I said you already, constant means fixed, variable means they don't have the fixed value, they are assigned different numerical values is called the variables. In a polynomial 3 plus 4y, I mean x and y are the variables. Okay. Next, degree. The highest power of a variable in the polynomial is called the degree of the polynomial. Okay. Since observing carefully in the polynomial example, 5x 2, it is not 2, it is x square. 5x square plus 3. Suppose you can assume this is the one polynomial, but in this case whatever the x is there, no, that degree or that power is 2. That's why this polynomial degree is 2. Next, constant polynomial. A polynomial containing one term only consisting of a constant is called a constant polynomial. The degree of a non-zero constant polynomial is 0. Suppose example C students, 3 minus 5 7 by 8 etc. are constant polynomials. Okay. Since constant polynomials means whatever in the equation only constant terms, such a type of equations we can call it as the constant polynomial. Okay. Suppose 3 also polynomial, minus 5 also polynomial, 7 by 8 also polynomial, but along with that there is no variables, there is no one more terms, only one term is there. That's why we can call it as the constant polynomial. Next, zero polynomial. A polynomial consisting one term only, namely 0 only, is called a zero polynomial. The degree of the zero polynomial is not defined. Okay. Since till now you can observe what is the polynomial. Okay. But in the polynomial, zero term is there. It means we can call it as the zero polynomial. Okay. Next. Types of algebraic expressions. Since till now we can observe the many types of expressions. That expressions we can bifurcate like this only. How we can bifurcate it? It means monomial, binomial, trinomial, polynomial. Okay. Let us discuss one by one. What is the monomial now? Algebraic expressions that consist only one term is called the monomial. Whatever the expressions is there, no, whatever the expressions in this, we have to observe only one term, I mean only 3x. Like this of expressions we can call it as the monomial. Binomial means algebraic expressions that consist two terms is called the binomial. Suppose 3x plus 4y, like this of expressions we can call it as the binomial. trinomial. Algebraic expressions that consist three terms is called the trinomial. That statement only tell the answer to her student. Okay, come on, observing in that statement they consist only three terms. I mean a 2x 3x, I mean 4y, like this. In the expressions only three terms is there. Such a type of equations we can call it as the trinomial. Polynomial. What is the polynomial? Algebraic expressions that consist many terms is called the polynomial. I mean in the equations many terms. So like this, I am 2x plus 3y plus 4z plus 8xy, like this is there. It means I mean more than three terms is there, means we can call it as the polynomial. Maybe I hope you understood. Okay, next, types of polynomial. Types of polynomial on the basis of degree only. Okay, let us see which are the types of polynomial. Linear polynomial, quadratic polynomial, cubic polynomial, biquadratic polynomial. Okay, what is the linear polynomial? A polynomial of degree 1 is called a linear polynomial. Since you know already how the polynomial, but in the polynomial whatever the variable terms is there, no, that variable terms degree must and should be only one is there. Such a type of polynomial we can call it as the linear polynomial. As it is quadratic polynomial, quadratic, I mean 2. Whatever the polynomial, in the polynomial variables is there, no, that variables degree must and should be 2. I mean highest power, highest degree is 2 is there, means quadratic polynomial. Cubic polynomial, a polynomial of degree 3 is called a cubic polynomial. I said you already, in the polynomial variables also is there, but highest power of the variable 3 is there. Such a type of polynomials we can call it as the cubic polynomial. Biquadratic polynomial, a polynomial of degree 4 is called a biquadratic polynomial. Next, which of the following expressions are polynomials in one variable and which are not? State reason for your answer. Okay, let us see the example, students. 4x square minus 3x plus 7. Okay, will you write once again that given example? 4x square minus 3x plus 7. Okay, so first you can observe here what is the variables and what is the constant in these expressions. Okay, here only one variable is there, that is x. Okay, in the first term x square is there, in the second term only x, in the third term there is no x. X is there but the degree must be 0. Okay, so observing carefully in the second step, 4x square minus 3x to the power of 1 plus 7x to the power of 0. X to the power of 0 in the sense of what? Only 1. Okay, next, here power of the equations, I mean degree of the equation is 210. What is the 210 here? Whatever the power of the variables is there, no, that is 2, 1 and 0. Since all powers are whole number, is it or not? Yeah, it is a polynomial. So all the powers are whole number is there. We can call it as the polynomial. Now, since there is only one variable, so in this equation you can observe in sense only one variable is there. That's why we can call it as the polynomial in one variable. Polynomial in one variable. This expression is polynomial in one variable x. Okay, next, write the coefficient of x square in each of the following. So you can observe in the one example 2 plus x square plus x. You can observe the expressions clearly. What is the here? 2 is there plus x is there, x square is there. So observing carefully, you learned already in the previous classes what is the constant, what is the variable, what is the degree, and where it is the coefficient. Okay, coefficient means where it is, how it is, you can understood already. Okay, plus x. This equations, sorry, this expressions you can write it once again. 2 plus x square plus x. Okay, in the second step we can observing 2 plus x square. So it's observing carefully, x square coefficient is 1. I mean before the x square, whatever is there in the behind of this, I mean x square behind back side ಏನಿದೆ ನೋಡ್ಕೊಳ್ಳಿ, ಎಕ್ಸ್ ಸ್ಕ್ವೇರ್ ಹಿಂದೆ ಇರ್ತಕ್ಕಂಥ ಟರ್ಮ್ನ ನಾವೇನಂತ ಕರಿತಾ ಇದೀವಿ, ಕೋಫಿಷಿಯಂಟ್ ಆಫ್ ಎಕ್ಸ್ ಸ್ಕ್ವೇರ್ ಅಂತ ಕರಿತಾ ಇದೀವಿ. ಸೊ 2 plus 1 into x square plus write as it is x write as it is. So x square coefficient is only 1. Okay, next coefficient of x square equals to 1. Okay, next give one example each of binomial of degree 35 and of a monomial of degree 100. Okay, binomial of degree 35 means a polynomial having two terms, highest degree 35. Okay, so it's binomial means I said you already, monomial means one term, binomial means two terms. Binomial means binomial of degree 35 means a polynomial. I mean in the expressions containing two terms is there, that such a type of expressions we can call it as the monomial or binomial. Suppose example, x to the power of 35 plus 1. Okay, t to the power of 35 plus t cube, y to the power of 35 plus y to the power of 34. But all those equations shows that only two terms containing one variable and two terms containing. Wherever the two terms is there, such equations, I mean such expressions we can call it as the binomial. Okay, next zeros of polynomials. Now we will discuss the zeros of a polynomial. Verify whether the following are zeros of the polynomial indicated against them. Okay, first you can take an example, p of x equals to p of 3x plus 1, x equals to 1 minus 1 by 3, and I mean they given one expressions and also they given x value. Now we want to find out it is zero of the polynomial or not. Okay, how we can find out? You can observe the below steps, students. Given, what is the given here? You can write it, p of x equals to 3x plus 1. Okay, putting x equals to minus 1 by 3, whatever the given is there, we can write as it is in the first step and also second step. You can observing third step. In the third step, what we have to do, whatever the x value is there, no, that x value we can substitute in the first expressions. Okay, what is the first expression here? Px equals to 3x plus 1. In that we have to substitute x value, I mean p into minus 1 by 3. Wherever x is there, you can substitute minus 1 by 3. Okay, next equals to 3. So x value minus 1 by 3 plus as it is 1 also as it is. So in the denominator, observing carefully, students, in the third step for RHS side, I mean 3 into 1 by minus 1 by 3. So here 3 get cancelled, remaining term minus 1 write as it is plus 1 write as it is. Minus 1 plus 1 obviously get cancelled, remaining will be 0. Okay, since p of minus 1 by 3 is equal to 0, therefore finally we can getting the answer 0. Therefore x equals to minus 1 by 3 is a 0 of the polynomial. Okay, next find p of 0, p of 1, p of 2 for each of the following polynomials. Okay, now we want to find out the each of the polynomial. How we can find out? Let us see one by one. Given expressions, we can write it as it is. First, whatever the given here, p of t equals to 2 plus t plus 2t square minus t cube. Okay, first in the first we have to substitute. We have three values, I mean 0, 1, 2. In the first case, we can substitute instead of t, equals to 0. Okay, so P of 0, I mean, in observing students, whatever the beginning step, I mean, whatever the given equation is there, no, in that equation, instead of t, whatever the variables is there, no, that variables, instead, we have to substitute 0. We have to substitute 0. So, P of 0 equals to 2 plus 0 plus 2 of 0 whole square minus 0 whole cube. So 2 write as it is, 0 write as it is, 2 into 0 square, it means 2. 0, I mean 0 is multiplied by anything, it means 0 only. So 0 cube means 0. So write it as it is, remaining 2. As it is only going on, putting t equals to 1. I mean t value 1 we can substitute in the proper equation. I mean P of t equals to 2 plus t 2 cube minus t cube is there, no, in that equation we have to substitute t value equals to 1. Okay, that's why P of t, I mean P of 1 equals to 2 plus t means 1 plus 2 into t square means 1 square minus 1 cube. 2 plus 1 plus 2, 1 square it means 1 into 2 minus 1. So 2 plus 1 plus 2 minus 1. I mean simplify afterwards we'll getting the we'll getting 4. Putting t equals to 2, that is also same to same. P of 2 equals to 2, right, as it is, plus t value 2 plus 2 t square, it means 2 square minus t cube means 2 cube. So 2 as it is plus as it is, 2 as it is plus as it is, 2 as it is, next 2 square means 4, I mean 2 into 2 is 4, equals to 2 cube means 2 into 2 into 2, I mean minus 8. Okay, next simplify all those things, we'll be getting the final answer 4. Okay, come to next. Find the zeros of the polynomial in each of the following cases. I mean, p of x equals to x plus 5. P of x equals to 0. Therefore, x plus, I mean, p of x value, what is that? X plus 5 equals to 0. X equals to minus 5. X equals to minus 5 is the 0 of the polynomial. I mean, wherever the x is there, in that we have to substitute minus 5. It means we will getting the finally 0. That's why x equals to minus 5 is a 0 of the given polynomial. Okay, next. Find the 0 of the polynomial in each of the following cases. This is also as it is in the previous example, students. You can do it yourself only. Okay, next. Factors theorem. Okay, let p of x be a polynomial of degree n is greater than 1 and let be a any real number. If p of a equals to 0, then x minus a is a factor of p of x. Next, determine which of the following polynomial has x plus 1 a factor. Okay, since here this is very important. Whatever is there now here, very important to in your further concept. You can observing carefully, determine which of the following polynomials has x plus 1 a factor. So the given equation x cube plus x square plus x plus 1. Okay, finding reminder, when x cube plus x square plus x plus 1 is divided by x plus 1. Okay, students, we have to divide, this is the dividend, this is the divisor. Obviously you know how to divide the given numbers till now, but we want to learn now how we can divide the given expressions. ಅಂದರೆ ಇಲ್ಲಿ ತನಕ ನೀವೇನು ಕಲ್ತಿದ್ದೀರಾ, ನಂಬರ್ಸ್ನ ಡಿವೈಡ್ ಮಾಡೋದನ್ನ ಕಲ್ತಿದ್ದೀರಾ. ಬಟ್ ಈಗ ನಾವೇನು ಕಲಿಬೇಕಾಗ್ತದೆ, ಎಕ್ಸ್ಪ್ರೆಷನ್ಸ್ನ ಡಿವೈಡ್ ಮಾಡೋದನ್ನ ಕಲಿಬೇಕಾಗ್ತದೆ. ಹೌ ವಿ ಕ್ಯಾನ್ divide the expressions? Let us see one by one. Divisor equals to 0. X plus 1 equals to 0. X equals to minus 1. Step 2. P of x, I mean given expressions, x cube plus x square plus x plus 1. In this case, whatever is the x value, minus 1. So substitute as it is. P of x means P of minus 1 equals to x cube means minus 1 cube plus x square means minus 1 square plus x means minus 1 plus 1, write it as it is. As it is, simplify. Minus 1 means minus 1 plus minus 1 square means plus 1, minus 1 means minus 1 Plus means plus, 1 means 1. Okay, since whatever here minus 1 cube minus 1 square is there, no, this multiplication by that time you can observing sign also. It is most important. Okay. Next, minus 2 plus 1 plus 2 minus 1. So, finally, we'll simplification afterwards getting the answer 0. This remainder equals to p of minus 1 equals to 0. Since remainder is 0, x plus 1 is a factor of 2x cube plus x square minus 2x minus 1. Okay. Next, determine which of the following polynomials has x plus 1 is a factor x cube plus x cube plus x square plus x plus 1. This is also same to same in the previous example. You can discuss yourself only, students. As it is, nothing will be changed. Okay. Next, only little changes is there. You can observing what is the changes, what is the difference of the previous example, and how you can do this example. Do it yourself and discuss yourself only. Okay. Next, I use the factors theorem to determine whether g of x is a factor of p of x in the following cases. Yeah, of course, students. This is also as it is same to same in the previous cases, but here they given separately p of x and g of x, two polynomials they given. But observing carefully, finding the remainder when 2x cube plus x square minus 2x minus 1 is dividend divide by x plus 1. I mean x plus 1, from x plus 1 we have to divide 2x cube plus 6 square minus 2x plus 1. Okay, put divisor it means obviously we know equals to 0. That's why x plus 1 equals to 0, x value minus 1. This value you can substitute in the given equation. P of x equals to 2x cube plus 6 square minus 2x minus 1. So putting x equals to 1 minus 1, I mean P of minus 1 equals to 2 into minus 1 whole cube plus minus 1 whole square minus 2 minus 1 minus 1. So, since carefully you can do the simplification, minus 1 whole cube again minus 1 will be getting. So, 2 into minus 1 plus minus 1 whole square, it means obviously will be getting plus 1 because minus into minus plus. Okay. So, plus 2 because minus 2 into minus 1, it means minus into minus plus, that's why plus 2 minus 1, write it as it is. Next, minus 2 plus 1 plus 2 minus 1. So final answer is 0. Thus remainder p equals to p of minus 1 equals to 0. Since remainder is 0, x plus 1 is a factor of 2x cube plus 6 square minus 2x minus 1. Okay. Next, find the value of k if x minus 1 is a factor of p of x in each of the following cases. This is also same to same, students. Nothing will be there. Whatever the dividend equations, expressions is there in that expressions they given, they won't given the constant term. So we want to find out the constant term here. So you can write it as it is and also substitute, discuss yourself. You will be getting the answer finally. You will be observing carefully and do it yourself. Next. Okay, students, observing here, factorize. How we can factorize the given expressions? 12x square minus 7x plus 1, 12x square minus 7x plus 1. We factorize using the splitting the middle terms method. Okay, since observing carefully, maybe I thought, I hope you learned how to factorize the term. Okay, but in this case 12x square minus 7x plus 1 is there, no. First we can this in these expressions we know what we know: first term, second term, and also third term. Okay, so how we can find out the factors for the 7x? It means, I mean not 7x, we can find out the factors 12x only. First we can multiply. See, students, in the beside of this we have to given already split the middle terms method. We need to find two numbers whose sum is minus 7, product is 1 into 12. 1 into 12, what is the 1 into 12 here? Where is it is? I mean this is the last term, this is the first term. 1 is the last term, 12 is the first term. I mean first term to last term, multiplication product, whatever is there, no, that product only we have to find out the factors. Okay, 3 and 4. So sum is 7, we want getting, product is 12. Like this only we have to find out the factors of the 12. Okay. Okay, so 12x square minus 4x minus 3x plus 1. In this case, I mean 7x, we have to split minus 4x minus 3x. Okay, observing first two terms, student, 12x square minus 4x. In this case, we have to extract. We have to take out common from that only 4x. In the first term, 3x is remaining minus as it is. In the second term, 1 as it is. Okay. So minus 1 common factor last two terms. 3x plus minus 3x plus 1 is there now. In this, we have to take out from common, take out common from that, so minus 1. Okay, remaining in the first term 3x, remaining in the second term minus 1, write it as it is. So observing students, in the second step, in the second in the second step, 3x minus 1, 3x minus 1 same is there, that's why you can write only once. Next, 4x minus 1, write it as it is. Okay, next, algebraic identities. Since all the identities you familiar already, you know already, once again I will be recall this. Okay, from this identities only we have to solve the problem, so you can observing and also you can learn perfectly. Next, uh, you remember this also. X plus y square equals to x square plus 2xy plus y square. X minus y square, it means a minus b whole square formula. A square minus b square plus b minus 2 ab. I mean here x minus y, y variable they will take. That's why x square minus 2xy plus y square. X plus y into x minus y equals to x square minus y square. X plus y cube, y plus z whole square equals to x square plus y square plus z square plus 2xy plus 2yz plus 2zx. Like this only you can observe the all identity, students. Next, use suitable identities to find the following products. Students, observing carefully, x plus 4 into x plus 10. For this, we have to choose the formula. What is the similar or is there? I mean x plus a, x plus b equals to x square plus a plus b into x plus ab. This equation is similar to this identity. Okay, so putting, observing and comparing the equations and also formulas. Observing and compare the formulas and equation. Okay, so x plus 4 is there, x plus a is there, x plus 10 is there, x plus b is there. As it is same is there, that's why x value as it is, a value 4, b value 10. So whatever a value, whatever b value, we can substitute in the formula, that's all. X square, it means write as it is, a means 4, b means 10, x write as it is, plus also write as it is, ab I mean 4 into 10. So x square, 4 plus 10 means 14x plus 10 into 4, 40. Okay, next, this is also same to same, students. 100 not 3 into 107. Okay, 103 into 107. 103 can be written as 100 plus 3. 107 can be written as 100 plus 7. This is also same to same for this identity. I mean, which identity here? X plus a, x plus b equals to x square plus a plus b into x plus ab. So observing and carefully comparing, so what is the x value, what is the b value, what is the a value, identify yourself and also substitute in the given equation, in the given formula, then finally we'll be getting the answer 11,021. Okay, as it is similar is there. Okay, you can observe it yourself, but here x value 100 is there, a value 3, b value 7, all those things you can substitute in the formula only. So this is also same to same in the previous example. You can observing and comparing, then you can discuss yourself. So observing carefully whatever the x value, whatever the a value, whatever the p value. Okay, next, factorize the following using appropriate identities. So in this case also very easy example, you can observing and also do it fast. 9x square plus 6y plus y square. 9 can be written as 3x square, right as it is, x square right as it is, plus 6xy plus y square. So 3x square means 3x whole square plus 6xy plus y square. 3x square plus 6x square means 2 into 3xy, so plus y square. So observing students carefully, this expression is completely related to the, I mean completely similar to the a plus b whole square formula. I mean a square plus b square plus 2ab. Now you can comparing these two, then will you getting the answer. What is the a value? 3x. What is the b value? Y. So now you can directly write it for the um, values. I mean a plus b whole square. A means 3x plus y means b means y. So 3x plus y whole square. 3x plus y whole square means 3x plus y into 3x plus y. Okay. Next, this is also same to same students in the previous example. I mean, in this case, we have to using the a plus b plus c whole square formula. So observing carefully what is the a value, what is the b value, what is the c value, and also substitute and simplify. Okay. Next, in this case also a plus b whole cube formula only we have to using. This is also same to same. So students, all the steps I given to you, and whatever is there you can identities and also given formula you can comparing and also getting the values, I mean a value and b value, and substitute yourself and also find out the answers. Okay. Next, in this case also same to same in the previous example. Here sign only change, 2a minus 3b. Okay, so do it yourself. Thank you once again. If it is there any doubt, please ask me.